Okay, so before we talk about how to expand the sniffing space, let me explain the active network devices and the routers, hubs, and switches. Hub is commonly used to connect segments of a LAN, which is a local area network, and a hub contains multiple ports. When a packet arrives at one port, it is copied to the other ports so that all the segments of the LAN can see all of the packets. Hub acts as a common connection point for devices in a network. Now, switch operates at the data link layer, layer 2, and sometimes the network layer, which is layer 3 of the OSI reference model, and therefore support any packet protocol. Now, LANs that use switches to join segments are called switch LANs, or in the case of Ethernet networks, switched Ethernet LANs. In basically all networks, switch is a device that filters and forwards packets between LAN segments. A router is connected to at least two networks, commonly two LANs or WANs, which are the wide area networks, or a LAN and its ISP, which is the Internet Service Provider's network. Router is generally located at gateways, the places where two or more networks connect. Using headers and forwarding tables, router determines the best path for forwarding the packets. And in addition, the router also uses protocols such as ICMP, Internet Control Message Protocol, to communicate with each other and configures the best route between any two hosts. So, in a word, router forwards data packets along networks. Now let's compare the hub and the switch, since both of these two devices have similar roles on the network. Each serves as a central connection for all of your network equipment and handles a data type known as frames. Frames carry your data. When a frame is received, it is amplified and then transmitted onto the port of the destination PC, which is typically a personal computer. The big difference between a hub and a switch is in the method in which frames are being delivered. You got that? In a hub, a frame is passed along or broadcast to every one of its ports. It doesn't matter that the frame is only destined for one port. The hub has no way of distinguishing which port a frame should be sent to, right? So passing it along to every port ensures that it will reach its intended destination. Now, this places a lot of traffic on the network and can lead to poor network response times. You can only imagine, right? Besides, the frame is received by the unintended nodes, which could be hackers. And in a cybersecurity point of view, what about the confidentiality? And additionally, on a 10100 megabit per system hub, it must share its bandwidth with each and every one of its ports. So when only one PC is broadcasting, it will have access to the maximum available bandwidth. However, if there are multiple PCs broadcasting, then that bandwidth will need to be divided among all of those systems, which will degrade performance for everybody. So in comparison, a switch keeps a record of the MAC, which is the media access control address of all the devices connected to it. With this information, a switch can identify which system is sitting on which port. So when a frame is received, it knows exactly which port to be sent to, without significantly increasing network response times. And in addition, unlike a hub, a 10100 megabit per second switch will allocate a full 10100 megabits per second to each of its ports. So regardless of the number of PCs transmitting, users will always have access to the maximum amount of bandwidth. That's important. So it's for these reasons that a switch is considered to be, well, let's say a much better choice than a hub, right? Good.